right, another version of Patio Productions coming right at ya. We are in the midst of a study of section 16-3. This is going to be our third of 4 lessons. Just remember making little manageable chunks so that we don't freak out. And so today, what's going to be really important is the algebra that's going to happen. So I'm super excited. I'm super jazzed. And so we're going to talk about the algebra. So let's actually just jump right in here and get started if that's okay. What we're going to do is we are going to talk about section 16-3. This is our third day on this, okay? So what we've done so far is we've talked about how to find the slope of a tangent line at a particular point. We've talked about how to write the equation of a tangent line at one of those particular points. I know, way fun stuff that we've done so far, but we also want to be able to do this in general and not necessarily like at a particular point. And that's what we're going to talk about today, okay? So our first thing, it says often the question will want a general answer instead of a specific one. Okay, so what this means is that our normal guide that we've been doing was something like this, like along this lines, the limit as x approaches 1 of f of x minus f of 1 over x minus 1. But now, instead of having it be like a 1 or something like that, we are just going to have it be at the general spot x equals c. And that has its own sort of like unique parts to it, okay? So the best way to do this is to learn by doing. And what I have provided for us today is 3 examples. The algebra is different for all 3 of them. I know, I'm a giver. You're welcome. You're welcome. And just to get you like to explore all the kinds of different algebra, and then you should be fully prepared to attack all of your homework questions. Okay. So the instructions for these are all the same. It's just going to say find the slope of the curve at point P, which is not specific this time, right? It's going to be at C and then F of C. So we're just talking about in general, just a general spot. Okay. Part A of our question, we're going to have a part A, a part B, and a part C. Part A says f of x is equal to 2x squared minus x. Again, stay in the algebra, okay, guys? If you're confused, pause the video. Do what you need to do, but I just want to make sure that the algebra is strong, right? We want to be like this with our algebra powers, okay? We want to be super good at our algebra powers. So let's set this baby up. First thing we're going to write down is the notation. Okay, the slope of this curve is going to be m, which is equal to the limit as x approaches c of f of x minus f of c all over x minus c. Okay, f of x is just going to be our original equation. F of c, oh, some fun things driving by. Isn't that the joy of Patio Productions? You know what I'm saying? I do love a good Patio Productions. I do. I love a good Patio Productions when something fun drives by. I love it. Okay, so we're going to do f of x minus f of c over x minus c. I think I was saying that f of x is just 2x squared minus x. F of c, we're just going to put in c. So it's going to be 2c squared minus c. So let's put those babies together. So we have the limit as x approaches c. Again, I would like to remind you, ladies and gentlemen, if you're not putting the limit as x approaches c first, you are wrong. It is the beginning of our math sentence, and you must put this part in. So the limit as x approaches c of 2x squared minus x, that's f of x, minus 2c squared minus c, that's f of c, all over x minus c. We are, in fact, going to distribute this negative as well as probably rearrange this baby, okay? So for the next line, we're going to write the limit as x approaches c, and it's going to say 2x squared minus x, now minus 2c squared plus c. Okay, that is going to be now, I'm going to rearrange this because the whole time that we've been doing the ones in the previous lessons, right, like the previous ones, there was something that you could do like with this algebra up here. I am going to erase this in just a second. All of this algebra so that you were able to get an x minus c, so then this guy would cancel, okay? And so that is basically what I want us to now take a look at, okay? So I want to figure out a way to factor this top guy so that we can get an x minus c so that it will cancel with the bottom. Wait, why am I doing that again? Okay, why? Because, folks, if we plugged in x minus c right now, everything would zero out on the top. Everything would zero out on the bottom. You would be sad because it would be 0 over 0, and that is mathematical nonsense. So what can I do to this top? I almost feel like it's going to be like a factoring by grouping question, and I'm going to like reorganize this just a teeny smidge. I'm going to do this as the limit as x approaches c, and it's going to be a 2x squared minus a 2c squared minus x plus c. I think then on that, I feel like what I can do is I can take out a 2 out of these two terms right here. I'm going to do that next. Okay. If I take out a 2, it also leaves me with, I'm just going to sort of like, I kind of like skipped a little bit of a step here. So it's actually a 2, and then it would be an x squared and then minus a c squared. And then of course you have magical algebraic powers. And so you know that this guy right here is a difference of squares. So this becomes the limit as x approaches c of 2 times x minus c times x plus c. And then I'm going to take away, take out a negative out of these two terms right here. So minus a 1 times x minus c. And this is factoring like grouping. Do you guys see that both of these terms of this binomial have an x minus c in common? Oh, that's so gorgeous. Let's factor that guy out. So it's going to say the limit as x approaches c of x minus c, and then times the quantity. What was left over was a 2 and x plus c, and then a minus 1. And then now, so beautiful, so exciting, these two babies cancel. I know. And all you're left with is the limit as x approaches c of 2 times the quantity x plus c, and then minus 1. And now we can finally plug in c for the x value right here, and it won't zero out. So I'm going to plug in c. You don't have to write the limit anymore because you've now plugged in the value. You get 2 times c plus c minus 1, and that simplifies to be 4c because c plus c is 2c, and 2 times 2 is 4, and our answer is 4c minus 1. Look how fun that was. Okay, so I think that what you're seeing right now, if you were to just pop into this slide right now and you were to look at it, you would be like this. That seems scary. And we'd be like, no. As we went step by step by step, everything was fine, okay? You have to stay organized. You have to be a professional algebra person, okay? And then you just have in the back of your mind that every single time what's going to happen is that this x minus c is going to go away on the bottom, and we got to get an x minus c on the top. If you can sort of keep that in the back of our mind, you will be golden. It'll be amazing. Let's do another example with a little bit different function. Okay, this second example says that f of x is equal to x cubed plus 2x. So I've now changed it a little bit by putting in x cubed. Not a problem. We're going to be able to figure this out. Okay, so again, use our algebra skills, follow the algebra, pause it if you need to, of course. So here we go. We start by the definition, the limit. Okay, our slope is the limit as x approaches c of f of x minus f of c all over x minus c. Okay, I put in the f of x function, which is just this. I put the f of c function, which would just be this, but with c's, and let's roll it. So here we go. The limit as x approaches c of x cubed plus 2x minus the quantity of c cubed plus 2c all over x minus c. Our next step is going to say the limit. I'm going to, in fact, I'm just going to distribute this guy right here, distribute and distribute. So I get x cubed plus 2x minus c cubed minus 2c all over x minus c with the limit as x approaches c in the front. Just like last time, we're going to reorganize this baby just a smidge. Okay, so I'm going to group the cubed guys together. So I have the limit as x approaches c. I have x cubed minus c cubed plus 2x minus 2c. Okay, out of these second two right here, I'm just going to factor out a 2. I mean, easy cheesy. Okay, but what do I do with these first two? Last time it was like a difference of squares. Wait a minute. Isn't this a difference of cubes? It is a difference of cubes. We can actually factor that, okay? So let's try to factor that. We got to sing the silly song. Take the cube root of the first and cube root of the second. Keep the sign. Then square the first, multiply together, square the last. Soup, chess hands. I know, so amazing, so amazing. Okay, so that's exactly what I did. For the limit as x approaches c, I have an x minus c in the front. Cube root of the first, cube root of the second, keep the sign. It's a negative. Then you end up squaring the first, so x squared. You multiply these two together, you get x times c. You square the last, which is a c squared. You do SOAP. It's the same sign, but then opposite sign, and then always positive. And then we talked about before how we were going to factor out a 2 out of that second part, and that's exactly what happened. Now look what happens. Look what happens. I'm so excited. They both have an x minus c in common. Woo-hoo! Let's factor that out because then we're going to cancel it. Okay, so we're going to have the limit as x approaches c of x minus c. I'm taking that out. And then what I'm left with is an x squared plus xc plus c squared plus 2 all over x minus c. The x minus c's cancel each other, folks. We now have the limit as x approaches c of x squared plus xc plus c squared plus 2. And now, dun, 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 we can plug in the c value and everything does not zero out. Yay, super exciting. So if I plug in c, every time I see an x, here's what I get. C squared. Then I get a c times a c, right? So let me see right here. This guy would be like c times c, which would be a c squared plus the original c squared plus 2. I have 1, 2, 3 c squareds. So I'm going to write 3c squared plus 2. And that is the most beautiful answer of what the slope of this curve at any point is going to be. Oh, that was beautiful and exciting. Ladies and gentlemen, you have now done 2 of these. I'm so proud of you. Let's dig in and do a third one. Okay, look at this one. This one has a square root symbol on it. Okay, so fun. Okay, so we're going to do f of x is equal to rad x plus 6. Now let's do it. Of course, we start this one like we do all the others by starting with the definition. Okay, it says the slope is the limit as x approaches c of f of x minus f of c over x minus c. We're taking the limit of the secant slope. We're going to plug some things in. So this is going to be the limit as x approaches c of rad x plus 6 minus rad c plus 6 all over x minus c. Now, we may be wondering what kind of algebra we should do to make these, like, get rid of these rads. Like, whew, this is crazy up here. So here's what I think, folks. What we did in our previous guys is you multiplied by the conjugate of the numerator. So this is the numerator. We've got 2 rads. The conjugate is just going to be the same 2 terms with a plus sign instead of a minus sign. That is where we are going to multiply the top and the bottom by. So we're going to multiply by a rad x plus 6 plus rad c plus 6 on the top and the bottom. Okay, on the top, we are going to distribute. So like if I distribute here and then distribute here and then go here and here, this is sloppy, but I think we can do it. The first 2 terms are going to square themselves out. It's just going to be an x plus 6. The middle 2 terms are going to cancel each other because there's a positive version and a negative version. And then we're going to have the minus of a c plus 6. And the bottom, like, do not under any circumstance multiply this out. Just let it be. We want to keep this x minus c all by itself because remember, we want it to cancel. That's what we're going for. Okay, so here we go. When I did the minus the c plus 6 for this numerator, I went ahead and distributed the negative. You can actually do that in another step if you want to, or just all at once. But some fun things happen, like kind of exciting things, okay? So really quick, guys, those 6s, these 2 6s, like, go away. All that you have left on the top is an x minus c. Like, didn't that, like, clean up so pretty and so cute? Okay, so we're going to get the limit as x approaches c of x minus c all over x minus c times that conjugate of rad x plus 6 plus rad c plus 6. These x minus c's are going to cancel each other, of course. I love it when they cancel. And here's what we're left with, okay, is a 1 over rad x plus 6 plus rad c plus 6. Now, if I go ahead finally at this junction, if I plug in c, every time I see an x, it does not zero itself out on the top and the bottom. So I'm going to plug that in, and here's what I get. A 1 over a rad c plus 6 plus a rad c plus 6. But now I have 2 of these, and that's exactly what we're going to simplify. Okay, notice, guys, that there was no limit here because I plugged in the c value. You don't have to write the limit anymore. And then this is our answer. Okay, 1 plus 2 rad c plus 6. Look at that, you guys. That was some amazing algebra skills. I am so proud of you. Okay. So your homework assignment is to just do, let's see, 27, 28, 29, 30, 31, 32, 6 questions. Like seriously, only 6? Jeez, why am I so nice to you? Okay. But they are all at the C value. That's what I want you to practice today. So you're going to do page 869, just 27 through 32. Do a good job. Practice your algebra skills. I think your guys are going to do amazing. Okay. So I think that's it. Let's get back in here. So that's it. That's the end of our lesson for today. I am so proud of all the hard work that you guys are doing. I want you guys to keep it up. I really feel like this is going to be such a strong chapter for you guys because we're taking our time. You're just like really digging deep into it and doing some good practice. I think that's it. All right. I'll send you on your way. Bye, guys. Have a good one. See ya.